So today topic is synchronous generator. Just using through the slides, just we discuss about the synchronous generator working principle and the types and the construction. What are the working parameters? This at all we discuss. Yes, synchronous generator. Actually, that synchronous machine or is run as a generator as well as run as motor. The synchronous machine is a constant speed machine. It can be run as constant. Okay, maybe the speed is fast or speed is slow, but it's a constant type of machine. That synchronous machine is a AC machine. The synchronous machine can act as a generator as well as motor. Okay. So normally, when we give the supply to the synchronous machine, when we give the supply to the synchronous machine, AC three-phase supply given to the synchronous machine. So the synchronous machine can be run. It can be coupled with a mechanical load. Okay, so here the electrical energy converted into mechanical energy, so this is called a synchronous motor. Instead of that, using prime mover, we rotate the synchronous machine to produce the electricity, that is synchronous generator. To produce the AC supply, that is synchronous generator. Another name is called as alternator. The real transmission real power generating system, this concept can be used. Okay, normally the synchronous machine is a double excited machine. Okay, its rotor poles are excited by DC current, and its stator winding are connected to the AC supply. Normally, no, in the synchronous machine, the stator side, the winding is that stator winding is called as armature winding. In rotor winding, no, that rotor winding is called as a field winding. So in this machine, the field winding can be rotate. So that's why it's called as a field rotating machine. Okay. Normally this machine can be classified into two types. One is high speed machine, another one is low speed machine. High speed machine is a non salient pole type. Low speed machine is a salient pole type. Okay, so through the diagram we discuss about what is by salient pole type, non-salient pole type. You see, this is the rotor construction in this like this. This is a salient pole type. The rotor construction is like that, is a non-salient pole type. Okay, so example, this is the non-salient pole type. Real power generation like steam power plant, nuclear power plant. So these areas, this non-salient pole type can be used. Okay, non-salient pole type. This is the construction diagram of the non-salient pole type. Okay, so this also non-salient pole type. This is a salient pole type. So the salient pole type is a slow speed machine. Slow speed machine. You see this one. This is a high speed machine. This is a high speed machine. This one, no, it's a slow speed machine. So this one hydraulic turbine and all used by salient pole type. So this is a salient pole type. This is a non-salient pole type. Okay. Oh, yes. It's a salient pole type. Yes. How that synchronous generator can be work? Normally, the through the prime mover, the field can be rotate. Through the prime mover, the field can be field winding can be rotate, meaning this rotor can be rotate. We give the DC excitation to the field. Normally, without excitation, we check the voltage here. Okay, no voltage can be produced here. Actually, what happened through the prime mover, this field can be rotate. It can be produced the electricity. Okay, initially we check very less voltage only produced. When we give the excitation, okay, due to that EMF can be induced, the three-phase AC supply can be produced. Actually, the mechanism of AC voltage generation, the rotor flux is produced by the DC field current. Rotor is driven by a prime mover producing rotating field in the air gap. A voltage can be induced in the stator winding due to the rotating field. Okay. So normally, what are the major parameters in this machine? One is synchronous reactance and armature resistance. Actually, we have two axes, meaning the stator MMF is locked with rotor MMF. Both the stator and rotor MMF can be locked only the machine can be run. Okay, so due to that stator and rotor mmf, this can be this can be classified as quadrant axis and direct axis. Okay, so the direct axis and quadrant axis how can be defined through this diagram shows. Okay, another one important concept, damper winding. Damper winding, no. So in this, this is the rotor. The top of the rotor, you see, top of the rotor, copper plate is there. Copper bars are placed here. Copper bars are placed here. What is the result of this damper winding? See here, copper plates, copper plates are fixed here. What is the use of this damper winding? So normally this machine can be helps to generate a AC supply, no? So whenever the speed can be increase or decrease the signal speed. Actually, this machine is a constant speed machine. So whenever can be speed can be increased as well as decrease, the torque is developed in the damper winding that opposes this change in the speed. This concept is called as hunting. Okay, that purpose this damper winding can be used. Okay. So these are some information about the synchronous generator. Okay. So what are the things we discussed today? That what is the damper winding? What are the direct and quadrant axes? Next, what are the parameters? How the signal generator can be work? What are the two different type of synchronous generator? One is salient pole, and one is non-salient pole. This is non-salient pole type. This is salient pole type. Salient pole type. Salient pole type. This is non-salient pole type. Non-salient pole type. Non-salient pole type. Okay, the difference of these two types. So non-salient pole is called as high-speed machine. That is, salient pole is the low-speed machine. Okay, so these are the information about the synchronous generator. You get some information about the synchronous generator. Okay.